Greetings, I'm Salvador Cordova. Welcome to the Evidence and Reasons for the Christian Faith video channel. I was thoroughly enlightened and inspired by Dr. Tour's outstanding and epic Abiogenesis series, as well as Dr. Tour's testimony before the United States Congress regarding graphene chemistry. Dr. Tour invited feedback on his Abiogenesis series, especially if there were any concerns, so I created a multi-part series of short videos to provide feedback that I think might improve some minor points, and I emphasize minor points. The first and second videos in the series I think are the most important. I'm going to provide pointers and nitpicks regarding thermodynamics and information theory that were mentioned only in passing in the Abiogenesis series. The video can also be seen as a complete affirmation of Dr. Tour's approach of mostly steering clear of information theory and thermodynamics, but sticking to basic chemistry arguments in his analysis of the Abiogenesis research enterprise. I've been a molecular biophysics research assistant for various scientists over the last several years. Prior to that, I held the title of scientist and engineer when I was in the aerospace and defense industry. However, I would dare not fancy myself a scientist in the area of molecular biophysics, at least not yet. I have a background in the study of statistical mechanics and thermodynamics from my graduate studies in physics at Johns Hopkins University, as well as a background in information theory from my undergrad studies in electrical engineering and computer science. I also have graduate training in biology from the FAES Graduate School at the NIH. For the record, I am an ID proponent and a creationist, and I was featured in the cover story of the April 27, 28, 2005 edition of the prestigious scientific journal Nature regarding my promotion of the intelligent design hypothesis. This video was hastily put together at the request of the producer of Dr. Tour's Abiogenesis series, and thus I myself probably have a few things I can improve on in this video. I make this video available to Dr. Tour and to everyone. With that said, let me now present my nerd pointers. A critique of thermodynamic and information theory elements of the Abiogenesis series by James Tour. This is definitely a nitpick because thermodynamics and information theory were mentioned only in passing. I'd estimate only 2% at most was of the entire Abiogenesis series was spent talking about this. So that's definitely in passing, and this is definitely a nitpick. If anything, I am just suggesting that this 2% mention could be totally dispensed with because it's unhelpful. It centers around the comment, the reference to the work of Dr. Brian Miller, who is a very fine scientist, and some of his discussion of thermodynamics and abiogenesis. Dr. Miller is, I consider, a colleague. He's a fellow ID proponent and Christian. He knows who I am, and I know who he is. We have had only friendly exchanges, but we have disagreements. To illustrate the disagreement, let me make some observations. A warm living human has way more thermodynamic entropy than a frozen dead mouse, based on standard molar entropies of water alone, and the fact that thermodynamic entropy is proportional to the number of moles. Let me state the important point. A warm living human has way more thermodynamic entropy than a frozen dead mouse. So having more entropy is not necessarily a bad thing, because that frozen dead mouse has less entropy than a warm living human, but the warm living human is alive. Next, Gilbert N. Lewis of Lewis structure fame said, "Gain in entropy always means loss of information and nothing more." For the sake of this presentation, let us call this the Lewis principle of thermodynamic entropy and information. And I got this from Wikipedia, the quote, and that's the reference there. Now, If a warm living human has supposedly more thermodynamic entropy than a frozen dead mouse, then conversely, a frozen dead mouse has more thermodynamic information than a warm living human. Does that sound absurd? Yes, it does sound absurd. This apparent absurdity results from conflated and equivocated meanings of information. The idea of loss and gain of information in thermodynamics can be, not necessarily, but can be the exact opposite of what we mean as gain and loss of information in the conventional sense. Including the second law of thermodynamics and information theory in a critique of abiogenesis research is like walking a minefield of unnecessary confusion. Invoking second law concepts with information theory is like swatting a fly with a sledgehammer. I suggest we use other tools if available to deal with the fly. Use a sledgehammer for breaking up rocks, not killing flies, figuratively speaking. For the sake of completeness on the story of mice and men and the differences in entropy, I got these standard molar entropies right there from the Wikipedia water data page. And from other sources, we can estimate humans have around 40 liters of water in them, and a house mouse has around 30 milliliters. The ratio between humans and mice, the ratio of water between humans and mice is over 1,000. Therefore, because entropy is proportional to the number of moles, a warm living human can be estimated to have over 1,000 times more entropy than a frozen dead mouse. Now that's a very rough calculation. A more rigorous estimate can be accomplished by using the volume of water to calculate moles of water, then the moles of water to calculate entropy of water in each organism by multiplying the moles of water by the appropriate standard molar entropies. By the way, this can be done it should be able to be done by a college level chemistry student, a student of mechanical engineering, or physics. So this is I'm just taking standard textbook ideas here. Continuing on, the entropy of water is an approximation of the relative ratios of the total entropy between the organisms. Other refinements could be made to improve the estimate further. But the point is that by applying the Lewis principle of thermodynamics and information to the example of mice and men, a frozen dead mouse has over 1,000 times more thermodynamic information than a warm living human. Does that sound absurd? If so, that's exactly why this whole issue could be a minefield. Furthermore, taking the standard molar entropies that were just mentioned, consider that 1 mole of water is roughly 18 grams of water or 18 milliliters of water, which is about the volume of 2 ice cubes, depending on the size of the ice cubes, of course. We can calculate the change in thermodynamic entropy, or decrease of entropy, or equivalently the increase of thermodynamic information for 1 mole of water going from a standard liquid state to a standard solid state. To do this, I'm going to have to be very terse, and some of this will only be familiar to students of thermodynamics, but in the interest of time, I'm just going to blast through this. If we take the Boltzmann definition of entropy, that is S times Kb, which is Boltzmann's constant, times the natural log of omega, or W. I use the symbol W here because it's close in shape to the symbol omega. Omega, or W, is the number of microstates. Now microstates are it's a non-trivial concept. And it would take several hours of lectures to explain what the microstates are. But just suffice to say, we're counting stuff. We're counting stuff, and these are huge numbers. So large that we have to use natural logs. These are just enormous numbers of microstates, just gigantic. So that's this Boltzmann statement of entropy. It follows then that delta S, the change in entropy, is Boltzmann's constant times the logarithm of delta W. Thus, taking all these facts in consideration for our scenario of changing a 1 mole of water in the liquid state to the solid state, delta S, the change in entropy, equals the final state, the final entropy, which is highlighted in green. We just take the standard molar entropy of 41 joules per mole Kelvin in the solid state times 1 mole, minus the initial entropy, which is represented in red, 69.95 joules per mole Kelvin times 1 mole. That's the entropy in the liquid state, and we grind through the numbers and we get a result at minus 29 joules per Kelvin as the change in entropy. Now this figure here, this minus 29, can be related to the other equation above. So we have minus 29 joules per Kelvin equals Boltzmann's constant times the natural log of delta W. If we divide both sides of this equation by Boltzmann's constant Kb, we get this equation here. This equation here. And we'll notice then that the natural log of delta W is dimensionless. There are no units associated with it. And just moving on, so we have this value for the logarithm of delta W. And that equals, if we push through all the numbers using actually dividing by Boltzmann's constant, which is this number here, we get a number with a large negative magnitude, minus 2.1 times 10 to the 24th. Minus 2.1 times 10 to the 24th. Now, instead of natural logs, we can express this in terms of log base 2. That's simply accomplished by just dividing by the natural log of 2. And we can end up converting this number here into this number here in log base 2, minus 3.0 times 10 to the 24th Shannon bits of entropy. Now we can actually omit Shannon bits of entropy. That's more of a place marker, because Shannon bits of entropy is actually a dimensionless unit. Yes, there are dimensionless units. That's kind of a persnickety detail. We could have just expressed it as a number, but it's trying to distinguish what logarithm base that dimensionless number was calculated. And the amount of Shannon bits of entropy, the additive inverse is the Shannon bits of information. So that equals 3.0 times 10 to the 24th bits of Shannon information. That's the change. That's the increase in information just by chilling water to make 2 ice cubes. That's a huge amount of information. 10 to the 24th Shannon, 10 to the 24th bits is a huge number. So if we use the Lewis principle, then cooling the water results in a gain of information. Making ice cubes increases information in the Lewis sense of the word information. Does this sound absurd? That's because of the equivocal and conflated meanings of information being used in these discussions. So, a way to survive a minefield is not to walk in it in the first place, is not to walk into it in the first place. The meaning of information in thermodynamics is not the same as information stored in DNA. Removing DNA from a cell decreases thermodynamic entropy of a cell because it reduces the number of moles in the system. That is the cell. Thus, removing DNA is a gain of information in the thermodynamic sense, but loss of information in the functional sense. Thus, in the thermodynamic sense, a living human has more entropy, therefore less thermodynamic quote-unquote information than a frozen dead house mouse. This shows the risk of equivocating thermodynamic notions of information versus ordinary everyday notions. Moral of the story: using second law concepts and conflating thermodynamic information with functional information, such as stored in DNA, invites confusion. No need to explicitly invoke thermodynamics when simpler and clearer arguments will suffice. An example, the rest of Dr. Tour's Abiogenesis series that didn't mention thermodynamics or information theory was very effective, and I'm just arguing just do that. Well, this is mostly what I had to say for this segment. The next segment will be covering protein probabilities and whether it's helpful to use information theory to analyze the probability of proteins arising in a prebiotic soup. I'll actually argue that one doesn't need to use it. It actually is superfluous and will add terms of confusion that are not helpful. So thank you all the viewers who've watched this segment, and you all are invited to see the next segment in this series. Take care and God bless you.